Hello and welcome to the second lecture on network theorem. My name is Sumit Kumar Chaube and today we are going to discuss superposition theorem. Now, if a circuit has two or more independent sources, one way to determine the value of a specific variable, whether voltage or current through a branch, is to use nodal or mesh analysis, as we discussed this analysis previously. Okay. Another way is to determine the contribution of each independent sources individually and then add them together to get our variable. Okay. So this second approach of getting the individual contribution of independent sources is known as superposition theorem. Superposition principle states that the voltage across or current through an element in the linear circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone, while all the other independent sources are turned off. The principle of superposition helps us to analyze a linear circuit with more than one independent sources by calculating the contribution of each independent sources separately. However, to apply the superposition principle, we must keep two things in mind. That first one is that we are considering only one source at a time while all the other sources are turned off, and dependent sources are left intact. We don't remove, we don't change, and we don't consider dependent sources for removing or for while calculating their contribution. Is that clear? So the very first thing is that we have to contribution of each individual independent sources and dependent sources are left alone. Okay. Now here is a term which is basically turning off. So what do we mean when we say that we are turning off a particular device? Okay. It basically means that this voltage source or this current source will be removed. This will be out of the picture. The only thing is that it's going to leave behind its internal resistance. Okay. For example, if you remove this voltage source, which is an ideal voltage source, it's going to leave behind its internal resistance between these 2 points. Okay. And the internal resistance of a voltage source is basically 0. So this will be short circuited. Okay. This is what we mean by turning off. When we are turning off a independent voltage source, it's going to be short circuited. When we are turning off an ideal current source, it's going to leave behind its internal resistance and its internal resistance in infinity. That means that this will be basically open circuited. Okay. Because if there is infinite resistance, there cannot be any current flow. So it means it's as good as open circuit. Okay. So that's what we mean by turning off the voltage and current source. Okay. Now, to apply the superposition theorem, we are first going to turn off all the independent sources except one source. We are going to find output voltage or current due to that active source using the nodal and mesh analysis that we learned earlier. And then we are going to repeat this step for each and every independent sources. Okay. And in the end, we are going to calculate the total contribution by adding algebraically all the contributions due to the independent sources. Okay. We are not going to do anything with the dependent sources. We are only going to consider independent sources. So here we have an example. It's basically a 2-loop circuit. It has 2 meshes and it has basically 3 nodes here. Okay. And here we have 2 sources, 2 independent sources. We have 2 sources and we are going to consider them one by one. For example, first we are going to consider this 6-volt voltage source. Then we are going to consider this 3 ampere current source. And when we are going to consider this 6-volt voltage source, this current source is going to be removed. It is going to be turned off. And what we mean by turning off a current source is that these 2 points is going to be open circuited. Okay. When we are going to consider this current source, this voltage source is going to be turned off, and by turning off a voltage source, we are basically means that we are going to short circuit this branch. So let me solve this problem using nodal analysis first. And when we apply nodal analysis, we have to take one node as reference node. So this is our reference node, and we are making this as a ground node. Okay. Now this is going to be our voltage V, and this, since there is a directly voltage source connected between this and ground, this will be 6 volt. Okay. And here we have only one variable. Now we can directly apply a nodal analysis in one line. So in nodal analysis, we basically write KCL equation, Kirchhoff current law. So it means that total incoming current is equal to total outgoing current. So total incoming current at this point is 3, and outgoing current is V minus 0 divided by 4 plus V minus 6 divided by 8. Okay, if you simplify this, you will get 3 is equal to 3V minus 6 divided by 8, or you can say 3V will be equal to 3V minus 6 will be equal to 24, or 3V will be equal to 10, or V is equal to 3V will be equal to 30 and V will be equal to 10. Okay, so our output here using this nodal analysis turned out to be equal to 10. So now we are going to consider superposition principle. In that, first we are going to consider this voltage source. So here we have this modified circuit in which we are considering only voltage source, and current source has been turned off. What we mean by that, we have open circuited those terminal where current source was connected. Okay, so here we can find out the contribution due to this 6 volt voltage source, and this is V1, and V1 can be determined using the voltage division formula. So this is basically 6 times 4 divided by 8 plus 4, which is equal to 2 volt. Okay, so contribution in the total output V is basically equal to V1 plus V2, and V1 is the contribution of this 6 volt voltage source acting alone, and V2 is the contribution of current source acting alone. So V1 we have already determined, this is equal to 2 volt. Okay, now we are going to consider the current source which is acting alone. So here is our current source, and we have turned off our voltage source, and what we mean by turning off, that we have short circuited this branch. Okay, so now we can apply our nodal analysis here, and this is V2. It's a misprint here. Let's say this is V2. V2 is the contribution of this current source. Okay, so when we apply this, and we can apply our nodal analysis by making this ground. So V2, 3 ampere incoming will be equal to V2 divided by 4 plus V2 divided by 8, or you can say 3V2 divided by 8 is equal to 3, or V2 is equal to 8. Okay, we have already calculated the value of V1, so V will be equal to V1 plus V2, addition of individual contribution, algebraic sum of individual contribution, right? So individual contribution due to voltage source was 2 volt, and individual contribution due to this current source is V2, which is equal to 8 volt. So total 10 volt. Okay, so this is the same value that we got using nodal analysis, isn't it? Now there is not much difference here in the in the output, but we get a very well, we got a very well insight into the system by considering the superposition theorem. We got to know what is the individual contribution of each and every independent source. Okay, which we were not able to get when we were applying nodal analysis, isn't it? So we know that contribution due to this voltage source is 2 volt, and contribution due to this 3 ampere current source in this 4 ohm resistor is 8 volts. So total is 10 volt. Okay, so we now know which one is dominating source here, isn't it? So these are the things that we get to know when we apply superposition theorem. In the next lecture, we are going to consider next theorem. But before we will consider next theorem, we are going to solve certain problem based on superposition theorem. just to make this point right. But I will suggest you to solve as many problems as you can using this superposition principle. Thank you. I will see you in the next one.